Okay, question 6 and 7. Two students determine acceleration of free fall by chucking lead off a large building. As you do, the distance fallen by the lump of lead is 35 meters and time is 2.7. So we've got the distance, we've got the time. They imply in it that they drop it. Yeah, they release a lump of lead. So we know the initial velocity is 0. Okay, and they want to find acceleration. So we have to pick a CVAT that's got these four. We're going to go for S equals ut plus a half AT squared. Plug in our numbers, that's our distance. Because the initial velocity is 0, ut is 0, half times A times 2.7 squared. Rearranging gives us acceleration of 9.6 meters per second squared. Now that is the acceleration of gravity from these observations, because acceleration here is gravity. Okay. Stay and explain the effect of the value of G obtained if the students had used a tennis ball. Well, the bottom line is this is quite a good discussion because you need to think about the language a lot. Tennis ball's got less weight, it's got less mass, so it's got less weight. But the point is it's got less weight, which is a force. So the effect of air resistance would be greater, i.e. it would be, if you're doing a free body diagram of it, you'd have a situation with the two balls of the same size. Let's say one of them is a tennis ball, the other one's a lead ball. You know, you'd have a large weight and a small weight, but at a given velocity they'd both have the same air resistance. Now that of course is more significant proportion of this than that is to this, so the effect, although air resistance would be the same, it's the same size at a given speed, the relative effect of the air resistance would be less. Okay, so we can say the effect of air resistance would be greater, so they would get less acceleration at a given speed, therefore you'd end up with a lower value for gravity. That's the key thing there. Okie dokie. C, the graph and figure shows how the velocity changes with time for the lump of lead from the time of release until it's ground. Well, this graph here in the book is blatantly wrong, because it's, of course, if you look on the graph, 10 and 10, that's probably right. I've done there, 10 and 10, that's right. But the fact is, we know that it comes out with a value of 9.6. So this can't be a straight line, because if it was a you'd have to have gravity being 9.8, or we'd be on a different planet. Anyway, by the by. So the point is, it then wants you to sketch on the same axis a graph to show how it changed if a tennis ball were used. So it's going to start off the same. As it gets faster, at some stage, this is going to start to peel away and get flatter and flatter. This one should be curving a bit as well, but of course the books will. So this one should just be peeling a bit away. That's that. Right, question 7. Jumping out of a plane at a horizontal speed of 70 meters per second. If air resistance can be ignored and before he opens the parachute, find his horizontal velocity 2 seconds after jumping. Well, if it's the same, if there's no air resistance and he hasn't opened his parachute, then he's going to keep going at the same horizontal speed of 70 meters per second. So that's easy. His vertical velocity, well, that's V equals U plus AT, it's 9.81 times by 2. It starts off with 0 vertical velocity, we assume, because we know that because he's going horizontally. So his vertical velocity is 19.62 meters per second. And then we want the magnitude and direction of his resultant. So the velocity is going to be a squared plus b squared equals c squared, it's Pythagoras. Yes, it's going to give 73 meters per second. And then we want to basically say, well, that's his horizontal, that's his vertical. So we do tan theta is that over that, so shift tan or inverse tan of opposite of adjacent. That's going to give us the angle, which is 15.6 degrees to the horizontal. Now you could have found an angle from the vertical, which would of course be whatever that would be, 90 minus that, but it doesn't matter as long as you state the velocity and the direction to an angle against some reference, you'll get the marks for that one. Okie dokie, that is the last question for chapter 7 in the book, basically. Good luck, happy days.